The night air is thick with exhaust fumes and the acrid bite of burning rubber. A long column of trucks rumbles through the blacked-out French countryside, their headlights masked to a dim sliver in the cab of a GMC CKW. The driver grips the vibrating steering wheel, eyes straining to track the ghostly silhouette of the vehicle ahead. Suddenly, the drone of aero engines rips the night apart. Tracers streak down like luminous needles, punching through canvas tops and chewing into the wooden cargo beds. The driver stomps the accelerator, the 270 cubic inch inline six screaming under the strain. But there is no evading this road. The survival of the entire front depends on this one truck, and 1,000 others just like it, grinding forward hour after brutal hour. But how did this simple, almost crude machine become the indispensable backbone of a global war machine? To understand that, we must step back to a moment when the United States Army possessed almost no specialized tactical vehicles at all, and to the frantic, high-stakes sprint that produced the very first one. In 1940, the Quartermaster Corps summoned a handful of automobile manufacturers and laid down an audacious challenge. Design and build a quarter-ton four-wheel drive truck that weighed under 2,100 pounds, could carry 3 men and a light payload, and could be produced quickly. No American firm had ever mass-produced such a small all-terrain vehicle, and the engineering risks were enormous. 3 companies answered: the Bantam Car Company of Butler, Pennsylvania, Willys Overland of Toledo, and the Ford Motor Company. Each was given a mere 49 days to deliver a running prototype. Bantam, a tiny firm fighting for its economic life, threw every ounce of its energy into the project and was the first to ship a completed vehicle to the Army's test center. That first prototype, the Bantam BRC, was a pure exercise in utilitarian sparseness. Its body was fashioned almost entirely from flat-sheet steel, with the only curves appearing around the cowl and the leading edges of the front fenders. The rear corners were squared off sharply, and the floor of the earliest units used corrugated steel for rigidity, while later examples switched to smooth panels with hat-channel reinforcements beneath. The windshield frame was square steel tubing, the headlights sat recessed deep inside the front fenders, and a Continental BY4112 four-cylinder L-head engine produced 45 horsepower through a 3-speed transmission and Spicer axles. It looked like nothing the Army had ever seen. An angular, almost homemade machine that weighed barely more than a delivery van. Ford's GP prototype was a much more refined animal. Its stamped body panels had rounded openings and a smooth, almost civilian grace to them. Under the hood, a modified tractor engine displaced 119 cubic inches, but its transmission lacked synchromesh, making every gear change a rough, metallic negotiation. Willys, meanwhile, held a secret advantage. A 134 cubic inch engine that produced 60 horsepower, a figure that crushed its competitors by a wide margin. The Army put all 3 prototypes through a gauntlet of sand, mud, and steep grades. The Bantam was the lightest and most agile. The Ford showed superior suspension flex over rough ground, but it was the Willys MA that impressed the evaluators most deeply, its raw power allowing it to climb slopes where the others stalled. In July of 1941, Willys Overland was awarded the production contract, its engine having proven the decisive factor. Yet the demand was already far beyond any single factory's capacity. Ford was brought in to build the identical design under license, producing it as the GPW. The standardized Jeep, the Willys MB and Ford GPW, featured a 54 horsepower L-head four-cylinder, a 3-speed synchromesh transmission, and a 2-speed transfer case. Its combat wheels could be run flat for short distances, and the simple channel frame could absorb enormous punishment. By the end of 1941, the production lines were turning, and the all-purpose quarter-ton truck was born. While the Jeep took shape, Dodge was busy adapting its commercial truck line for a heavier military role. In late 1941, the company introduced the WC Series half-ton four-wheel drive vehicles. These early Dodges used a civilian pickup cab and a distinctive curved grille made of solid steel bar stock, paired with a hood that sloped upward toward the cowl. Underneath, a 217 or 230 cubic inch L-head 6-cylinder sent power through a 4-speed transmission and a single-speed transfer case. No low range was yet available. The half-ton came in a bewildering variety of body configurations: a closed-cab pickup, an open-cab weapons carrier, a command car, and even a panel ambulance. The pickup's cargo box was narrow by later standards, but it had stake pockets for troop seats and a canvas top. Running boards and civilian-style fenders gave it a familiar look, but the pintle hitch, blackout lights, and military paint marked it as a machine built for war. As 1941 drew to a close, Chevrolet also turned its massive production capability toward the military. The G7 107 1.5-ton four-wheel drive cargo truck was a direct military adaptation of the company's standard civilian workhorse. A 235 cubic inch overhead valve six-cylinder engine, coupled to a four-speed manual gearbox and a two-speed transfer case, drove both rear axles and the front axle. Dual rear wheels, a rear pintle hitch, and a simple steel or wood cargo bed made it a sturdy, uncomplicated hauler. These early trucks, the Jeep, the Dodge half-ton, the Chevrolet 1.5-ton, were the first tangible results of an industrial mobilization unlike any in history. They were built before the nation was at war, under immense pressure to standardize components and simplify production. In their simple steel frames and pragmatic engineering, they carried the genetic code of every American military vehicle that would follow, a philosophy that valued reliability, interchangeability, and sheer volume above all else. In the bitter January of 1942, the Dodge Brothers engineering team in Mound Park, Michigan, faced a brutal truth. Their half-ton WC series, noble as it was, simply could not shoulder the punishment of total war. The frame flexed under heavy loads. The narrow express cargo box limited what troops could carry. The tall civilian-derived silhouette stood out against every ridgeline. So Dodge took a radical step, designing the first vehicle the division had ever built from the ground up strictly for the military, designated the WC-51 3/4-ton weapons carrier. The new truck rolled into service in March of 1942, and a mechanic kneeling beside it would immediately spot the transformation. The frame was now double-dropped, plunging lower between the axles to strengthen the chassis and pull the entire body down closer to the dirt. The curved sheet metal grille of the half-ton was gone, replaced by a stark, flat barrier of heavy steel bar stock that could absorb brush and small arms fire without bending into the radiator. Under the hood, the 230 cubic inch L-head six-cylinder now produced a full 92 horsepower, and the axles carried a brutally low 5.83 to 1 gear ratio, sacrificing highway speed for raw pulling power in mud and loose gravel. The WC-51 sat lower and wider than any Dodge military truck before it. Combat wheels bolted onto hubs that spread the tread to 64.75 inches, creating a stable platform that resisted tipping even when the cargo box was stacked high with ammunition crates. Behind the cab, an all-new steel and wood cargo bed replaced the narrow civilian pickup box, storage lockers built into the rear corners under folding troop seats, tie-down hooks recessed into stamped dish-shaped depressions on the outside panels. A Braden 5,000-pound power takeoff winch, mounted squarely on the front frame horns of the WC-52 variant, could extract the truck from shell craters and drag disabled howitzers back into firing position. Yet for all its brute strength, this truck still employed only a single-speed transfer case, meaning the driver engaged the front axle without the benefit of a low-range reduction gear, a design compromise that heavy equipment operators would curse in deep mountain passes, but that kept the driveline simple enough for field maintenance under artillery fire. While Dodge reworked the light truck chassis, General Motors turned its vast industrial weight toward the medium-duty vehicle that would become the logistical backbone of the entire Allied war machine. In June of 1942, GMC's yellow truck and coach division began stamping out the CCKW 2.5-ton six-wheel drive cargo truck, and within 18 months, over 800,000 similar trucks from multiple manufacturers would be rolling off assembly lines from Detroit to St. Louis. The CCKW is the machine this documentary opened, with the truck shuddering beneath a driver's white-knuckled grip on a blacked-out French road, and it deserves a deeper look now, because this single vehicle moved more ammunition, more fuel, more rations, and more artillery shells than any other chassis in the American arsenal. Its heart was the GMC 270, a 270 cubic inch overhead valve, inline six-cylinder producing 91.5 horsepower at 2,750 revolutions per minute, with four main bearings and mechanical valve lifters that could be adjusted with a wrench and feeler gauge in a muddy field. The engine fed torque into a Clark 5-speed constant mesh transmission with overdrive, sending power rearward to a 2-speed Timken transfer case that split into 3 drive shafts, one forward to the front axle, and 2 stretching along the right side of the truck to the twin Timken rear axles. The rearmost shaft supported by a pillow block bolted to the forward rear axle housing. GMC built the CCKW with two distinct rear axle designs, and the distinction mattered to every mechanic in the motor pool. The split housing Timken axles were adjustable, using tapered roller bearings that could be precisely set with a torque wrench to extend gear life under constant load. The alternative was the GM-designed banjo axle, a single forged housing that was heavier and simpler to manufacture in quantity, but which lacked the field-adjustable bearings of the Timken design. The two types were not interchangeable. The entire frame, drive shafts, and transfer case had to match the axle configuration installed at the factory, a logistical headache that supply sergeants learned to solve by reading the serial number stamped on the front frame rail above the spring before ordering replacement parts. The CCKW came in a short wheelbase of 145 inches, with the spare tire and fuel tank squeezed between the cab and the 9-foot cargo bed, and a long wheelbase of 164 inches, with a 12-foot bed that could carry 5,000 pounds off-road or 10,000 pounds on hard surface highways. Both versions used dual rear wheels shod with 7.50 x 28-ply military non-directional tires, though some units swapped on the larger 11.00 x 18 single combat wheels from the DUKW amphibious truck to improve flotation in sand and deep mud. The cargo bodies themselves tell a story of America's rapid industrial mobilization. Early CCKWs carried an all-wood bed made by furniture manufacturers who had never built a military component before the war. As steel supplies stabilized, a mixed wood and steel body appeared, and by 1943, fully welded all-steel boxes were rolling off Budd Company presses, each one fitted with stake pockets for troop seat racks, removable canvas top bows, and a folding steel tailgate with a tool compartment bolted underneath. One out of every 4 trucks left the assembly line with a circular ring mount bolted above the cab, ready to accept a 50 caliber Browning M2 machine gun for anti-aircraft defense, operated by a soldier standing on the passenger seat and bracing against the windshield frame. The trucks also carried a 10,000-pound Garwood or Heil front winch on roughly half the units, the winch driven by a power takeoff from the transmission and routed through a series of universal joints to the front frame horns where a roller fair lead guided the cable. By the time the Red Ball Express began its frantic dash across France in late 1944, these CCKWs were absorbing punishment that no civilian truck designer had ever imagined. Their engines running at full throttle for 20 hours at a stretch, their brake vacuum boosters hissing under load, their drivers gunning through intersections while Luftwaffe fighters strafed the columns. In parallel with the trucks, the standardized Jeep program reached staggering proportions. Willys and Ford, now producing the MB and GPW as virtually identical machines, churned out over 600,000 units by the end of the war, each one fitted with combat wheels that allowed it to continue driving for short distances, even with punctured tires, the bead lock clamping the rubber to the rim so it could not peel off under fire. The Jeep's 54-horsepower engine was not powerful by the standards of the heavier trucks, but its lightweight and short 80-inch wheelbase allowed it to thread between shell holes and climb slopes that would roll a heavier vehicle onto its side. Radio-equipped models ran on 12-volt electrical systems with heavy-duty generators, while standard units used 6-volt systems. Both were fitted with full radio suppression kits that grounded every body panel and shielded every ignition wire so the vehicle could transmit without blasting static into the command net. As the Jeep established itself as the backbone of light tactical transport, Ford engineers took its chassis in an entirely different direction for a specialized mission. In January 1943, the Ford GPA amphibious Jeep entered production, now under the authorization of the second full year of war, and it was something altogether strange. A Ford GPW drivetrain sealed inside a boat, shaped all-welded steel hull, stamped with heavy ribbing to strengthen the panels against surf impact. The vehicle weighed 3,660 pounds, more than 1,000 pounds heavier than a standard Jeep, and it now required a power takeoff mounted on the rear of the transfer case to drive both a propeller for water propulsion and a bilge pump to expel the seawater that constantly seeped through the flexible rubber seals around the driveshaft tubes. A cable-controlled rudder, operated from a steering column lever in the cockpit, gave the GPA a water speed of about 5.5 miles per hour, enough to ferry scouts across a river or to approach a beach from a landing craft, but nowhere near enough to outrun a current. The crews who operated these seeps learned quickly that the vehicle's low freeboard made it lethal in anything above a light chop. They carried bilge pumps and life preservers as standard equipment, and they avoided rough water with the same reflexive caution that a tank crew reserved for open terrain, within range of an 88mm gun. By mid-1943, a different kind of vehicle was coming off the assembly lines, the half-track, a hybrid that combined the steering and front wheels of a heavy truck with the track-laying suspension of a light tank, designed to keep infantry moving at the same speed as armored columns across broken ground. White Motor Company, Autocar, and Diamond T all built versions of this machine, using a purpose-designed 386 cubic inch L-head six-cylinder engine that produced 128 horsepower and fed a four-speed constant mesh transmission, which in turn drove a two-speed transfer case and a pair of Timken axles. The rear axle bolted directly to the frame and spinning a small drive sprocket that propelled the endless rubber and steel track. The front wheels carried the weight of the engine and driver, using conventional leaf spring suspension and combat tires, while the rear track assemblies rode on four bogie wheels per side, mounted in pairs on pivoting arms connected to vertical volute coil springs that compressed and rebounded independently, allowing each cluster to rise over rocks and tree stumps without throwing the hull sideways. The armor varied from a quarter-inch to a full three-quarters of an inch of face-hardened plate, bolted together with countersunk armored screws, forming a box that could stop small arms fire and shell fragments, but could not withstand a direct hit from even the lightest anti-tank round. The half-track family splintered into a dozen specialized variants, each tailored to a specific tactical role. The basic M3 model carried 13 men and a pedestal-mounted 50-caliber machine gun, while the M2 variant dropped the rear door and shortened the body slightly to carry 10 men with a skate rail that ran around the entire interior, allowing a gunner to slide a machine gun trolley to any bearing and engage targets from any angle. The M4A1 mortar carrier mounted an 81mm mortar on a heavy base plate bolted to the frame behind the driver's compartment. Firing forward at high angle over the cab, the M15A1 combined a 37mm automatic cannon with twin water-cooled 50-caliber machine guns on a powered open turret, intended to chew apart low-flying aircraft and light ground vehicles. But the variant that soldiers remembered most vividly was the M16, its entire rear body transformed into a platform for the Maxon M45 quad-mount turret. 450 caliber barrels, clustered together and fed by 200-round reel-style ammunition chests, capable of putting out nearly 2,000 rounds per minute into a cone of sky above a convoy. When a German fighter made a low pass, the M16 gunner, reclining in a bucket seat inside the turret, would track the aircraft through a circular sight and squeeze the trigger. The combined muzzle blast from all four barrels, shaking the vehicle so violently that spent shell casings rained down on the armored floor like metallic hail. International Harvester entered the half-track program, with its own line, the M5 and M9, built for the Navy and Marine Corps, with thicker armor and a totally different power plant. A 450 cubic inch overhead valve, red diamond six-cylinder engine that put out 130 horsepower, coupled to an IHC-designed 5-speed overdrive transmission and a 2-speed transfer case. The M5 shared only the basic frame layout, bogie wheels, track and drive sprockets, with the white-built half-tracks, but its rear body sides were fabricated from single pieces of armor plate rather than bolted sections, and its instruments, wiring harness, brake linkages, and engine accessories were all IHC proprietary designs. The Marine Corps especially valued the M5 for its Hendrickson walking beam rear suspension, which used a pivoting steel beam to connect the two bogie clusters on each side, allowing the track to flex and conform to uneven terrain far more effectively than the white suspension could manage on soft volcanic sand. Most M5s were shipped overseas under Lend-Lease, equipping British, French, and Soviet units who found the truck's simple controls and thick armor a welcome improvement over their own domestic armored personnel carriers. As half-tracks began rolling toward the beaches of Normandy and the islands of the Pacific, the factories turned their attention to the heaviest class of vehicles, the tanks that would form the tip of the American armored spear. In January 1944, the M4 Sherman medium tank reached its peak production rate, eventually totaling over 57,000 units across all variants, a number that exceeded the combined tank production of every Axis power. The early Shermans carried a 75mm gun and a 9-cylinder Continental R975 radial aircraft engine, 973 cubic inch air-cooled monster that developed 400 horsepower and drank high-octane gasoline at a prodigious rate. Its cylinders arranged in a circle around a central crankshaft, its massive cooling fan drawing air through the engine deck grills and blasting it out through armored vents. As demand for radial engines soared, the Detroit tank arsenal turned to alternative power plants. The Chrysler A57 Multibank, a Frankenstein-like assembly of 5 6-cylinder car engines driving a common crankcase, and the twin General Motors 671 two-stroke diesels, each one a commercial truck engine adapted to tank service by mounting it in parallel with its twin and coupling the output through a shared bell housing. The most reliable of all, however, proved to be the Ford GAA, an all-aluminum 60-degree V8 with dual overhead camshafts and 4 valves per cylinder. Originally designed as a V12 aircraft engine, but shortened to fit the Sherman hull, producing 450 horsepower with a deep metallic growl that echoed through the tank's fighting compartment. The Sherman's armor varied from 2 inches on the front hull to as little as half an inch on the bottom plate, and the tank's vertical sides made it vulnerable to high-velocity German guns that could punch through the flat-face hardened steel at ranges where the Sherman's 75mm gun could not effectively reply. In response, the Army rushed the 76mm high-velocity gun into production, fitting it into a redesigned turret with a larger mantlet and a rear bustle for radio equipment. And by the final months of the European campaign, most Sherman units had replaced at least some of their older tanks with the upgunned variant. A separate line of Shermans mounted a 105mm howitzer in the standard turret, firing high-explosive shells on a parabolic arc to smash into German defensive positions and dug-in infantry. The gunner depressed the breech, and the assistant gunner shoved a 40-pound shell into the chamber, the breech block clanging shut as the commander shouted the firing command. The wet ammunition stowage, introduced midway through production, surrounded each main gun shell with a liquid-filled jacket of water and antifreeze, a desperate engineering fix designed to absorb the flash of a penetrating hit and prevent the catastrophic ammunition fires that had killed so many tank crews in the North African desert. The Sherman was not the only tracked monster to emerge from American factories. In June 1944, the DUKW 353 amphibious truck entered mass production. A specialized variant of the GMC CCKW chassis, sealed inside a welded sheet steel boat hull that could swim through surf and ferry supplies directly from ships anchored offshore to beaches where no port facilities existed. The DUKW used the same 270 cubic inch GMC engine as its land-bound cousin, but the drivetrain now included a propeller driven by a power takeoff from the transfer case, with a watertight stuffing box where the shaft passed through the hull, and a large rudder controlled by cables that ran from the steering column back to the stern. Its 6 combat wheels, all running on 11.00 x 18 tires, with bead locks that allowed them to operate at drastically reduced pressures on soft sand, were arranged in a single tire configuration so that the rear wheels tracked directly behind the front, compacting the sand only once and reducing rolling resistance. A central tire inflation system, controlled by a gauge and valve assembly on the passenger side of the cab, allowed the driver to bleed air pressure down to as low as 10 pounds per square inch for crossing loose beach sand, then re-inflate to road pressure using the engine-driven air compressor mounted under the front deck. On May 1, 1945, as the war in Europe entered its final week, an entirely new light tank reached frontline units. The M24 Chaffee, designed to replace the aging M3 and M5 Stuart series that had been outgunned and out-armored since the North Africa campaign. The Chaffee mounted a 75mm gun in a cast steel turret, the same caliber as the early Shermans but packaged into a hull that weighed less than 20 tons. With a torsion bar suspension that used dual rubber-tired road wheels on each of 5 stations per side, the track a wider 16-inch center guide design that spread the vehicle's weight across soft ground far more evenly than the narrow 12-inch tracks of the Stuart. Power came from twin Cadillac 346 cubic inch L-head V8 engines, each producing 110 horsepower, mated to hydromatic automatic transmissions, and combined through a synchronized transfer case into a single drive shaft that ran forward to a controlled differential in the bow of the hull. The driver steered with 2 levers that applied oil-cooled contracting bands inside the differential, braking one track while allowing the other to continue turning, and the tank could pivot in place by pulling both levers to the full rear position, the tracks churning mud in opposite directions. Though the Chaffee arrived too late to see extensive combat in Europe, it represented the culmination of every lesson the Army had learned about light tank design. low silhouette, sloped armor, wide tracks for flotation, and a gun large enough to threaten enemy medium tanks while being light enough to be airlifted and airdropped into remote battlefields. The war ended with production lines still running, and the legacy of these vehicles extended far beyond the last shots fired. Tens of thousands of CCKWs, Shermans, half-tracks, and Jeeps were left overseas, given as military aid to Allied nations who would use them for decades. While the vehicles that remained in the United States went into National Guard armories, surplus depots, and civilian hands, where farmers cut off the rear bodies and installed flatbeds, loggers swapped the gearing for slower crawler speeds, and collectors like the author of this catalogue began hunting for the survivors. The standardization of a handful of basic chassis had not only supplied the greatest military force ever fielded, it had created a mechanical ecosystem that would dominate the post-war decades, spawning the M37, the M35, the M151, and the M41 Walker Bulldog, all of which carried the engineering DNA of the Jeep, the Jimmy, and the Sherman forward into the Cold War and beyond. The first clear sign of this new direction appeared in January 1950, when Willys Overland rolled out the M38. From a distance, it looked remarkably like the wartime MB, but up close the differences were stark. The M38 was taller and heavier, riding on one-piece wheels and larger 7.00x16 tires. Its frame rails were thicker, the spring shackles redesigned, and the entire electrical system had been converted to a sealed, waterproof 24-volt configuration. The old 6-volt generator and exposed wiring harness, so vulnerable to moisture and mud, were gone. The engine was still the familiar 134 cubic inch L-head 4-cylinder, but it now produced 60 horsepower thanks to improved carburation and ignition timing. A new Carter YS637S carburetor and military spec distributor delivered a cleaner air-fuel mixture and more reliable spark. The transmission gained heavier synchronizers, and the transfer case received updated bearings and seals. These were not revolutionary changes, but they reflected the Army's new philosophy: design a vehicle that could operate in any climate, ford deep water with a sealed intake and exhaust system, and survive the brutal duty cycles of peacetime training. The M38's cargo body eliminated the small storage lockers in the rear wheel housings that had characterized the wartime Jeep. Instead, the Pioneer tools were relocated to the opposite side of the body, and a bolted-in tailgate replaced the fixed rear panel. A toolbox moved under the passenger seat, and the emergency brake lever was repositioned to the left of the instrument panel. These were ergonomic improvements, small adjustments that made daily operations slightly less punishing for the men who lived out of these vehicles for weeks at a time. 45,473 M38s rolled off the assembly line between 1950 and 1952, the lowest production run of any Jeep model. But the M38 was already being eclipsed before its production ended. In 1952, Willys introduced the M38A1, a machine so thoroughly redesigned that it shared almost no body panels with its predecessor. The most visible change was the elimination of the flat fenders that had defined every Jeep since 1941. In their place rose curved, sculpted fenders that swept down from the hood, giving the vehicle a sleeker, more modern profile. Under that new sheet metal sat an engine that represented a genuine leap forward: the Willys Hurricane F4-134, an F-head design with the intake valves positioned in the cylinder head and the exhaust valves remaining in the block. It produced 72 horsepower, a full 20% increase over the M38, and its compression ratio climbed to 7.4 to 1. The F-head configuration was an unusual hybrid between the old L-head flathead layout and a modern overhead valve design, a compromise that delivered more power without requiring a complete retooling of Willys's production lines. The same engine would later power the civilian CJ5, which debuted in 1955 and became one of the most successful recreational vehicles in American history. The M38A1's electrical system remained 24 volts, with the same sealed waterproof connectors pioneered on the M38. The batteries were relocated to a compartment inside the cowl, just ahead of the passenger's knees, a placement that kept them protected from splashing water and mud. The windshield was split into two panes of flat glass, rather than the single piece used on the M38, and a small vent beneath the center divider allowed a trickle of air into the cab when the windshield was upright. These were the kinds of incremental improvements that engineers could afford to make now that the desperate urgency of wartime production had passed. The Jeep was not the only vehicle undergoing transformation. In June 1950, Dodge introduced the M37 three-quarter-ton truck, a direct descendant of the WC series that had served so capably during the war. The M37 was wider and taller than its predecessor, with a cab that could seat 3 men and a cargo box that could carry 8 fully equipped troops. It rode on the same 230 cubic inch L-head 6-cylinder engine that had powered the late-war WC-51, still producing 78 horsepower. But almost every other component had been redesigned. The most significant mechanical upgrade was the 2-speed transfer case, which finally gave Dodge drivers a low range for crawling over obstacles at a walking pace. The World War II half-ton and three-quarter-ton Dodges had only a single-speed transfer case, meaning the front axle could be engaged or disengaged, but the driver had no additional gear reduction for steep grades or deep mud. The M37 corrected this deficiency, and its synchromesh transmission replaced the old sliding gear unit, making shifting smoother and reducing the grinding of gears that had been a constant soundtrack in the earlier trucks. The steering system received a complete overhaul. Instead of the conventional pitman arm and drag link arrangement used on the wartime trucks, the M37 employed a steering sector bolted to the outside of the frame rail, with a double drag link assembly that ran forward to a pivot point, and then back to the left front wheel. This geometry reduced steering effort considerably, a welcome improvement for drivers who had wrestled the heavy manual steering of the WC series through rutted tracks and shell-pocked roads. The turning radius tightened, and the wheel no longer required the driver to brace himself against the seat back to muscle the truck through a tight corner. Over 100,000 M37s and its variants were built between 1950 and 1968, serving in Korea, Vietnam, and countless Cold War garrisons. The M42 Command version added map lights, a folding table, and side curtains with non-glare plastic windows, while the M43 ambulance carried 4 litter patients in an insulated steel body with a sliding door between the driver's compartment and the medical bay. The basic M37 cargo truck came with or without a front-mounted Braden winch, now driven by a power takeoff from the transfer case, and could be fitted with a factory hard cab, an Arctic heater kit, and a deep-water fording system that allowed the engine to breathe through a snorkel raised above the windshield. While the Army refined its truck fleet, the armored branch faced a harder problem. The M24 Chaffee, for all its sophistication, was a light tank designed in 1944. Its 75mm gun could not penetrate the armor of the Soviet T-34s and IS series heavies that were now arrayed across the Iron Curtain. The Army needed a light tank that could kill other tanks, and it needed it quickly. The answer came in September 1951, when the M41 Walker Bulldog entered service, named after General Walton Walker, who had been killed in a Jeep accident in Korea the previous year. The Walker Bulldog was fundamentally different from every American tank that had come before it. For the first time, the power pack was not a radial aircraft engine with a separate transmission and differential, but a single integrated unit, the Continental AOS 8953, a 6-cylinder horizontally opposed air-cooled gasoline engine supercharged to produce 500 horsepower. Bolted directly to its rear face was the Allison CD 503 cross-drive transmission, a single assembly that combined the functions of gearbox, steering differential, and braking system into one compact housing mounted in the rear of the hull. This rear-mounted power pack drove the rear sprockets directly through planetary final drives, eliminating the long drive shaft that had run from the rear engine to the front differential in the Chaffee and every Sherman variant. The cross-drive transmission allowed the tank to pivot in place by driving one track forward and the other in reverse, a maneuver that the older controlled differential designs could not perform. The driver controlled the tank with a steering wheel rather than the traditional twin steering levers, a radical departure that reflected the influence of German tank designs studied after the war. The M41's main armament was a 76mm high-velocity gun, longer and more powerful than the 75mm weapon on the Chaffee. It was the first American tank gun to feature a bore evacuator, a bulbous collar near the muzzle that drew propellant fumes out of the barrel after each shot, preventing them from drifting back into the turret and choking the crew. A muzzle brake deflected the blast to the sides, reducing the dust cloud kicked up when firing from a prone position. 65 rounds of ammunition were carried, and the turret traversed under hydraulic power with manual backup. The armor was thicker than the Chaffee's, with 25mm on the front hull and 15 to 20mm on the sides and rear, but the Walker Bulldog was never intended to slug it out with heavy tanks. Its role was reconnaissance, flank security, and infantry support, using its 45-mile-per-hour top speed to outmaneuver threats it could not outgun. The suspension was torsion bar, with 5 dual rubber-tired road wheels per side and 3 return rollers supporting the upper track run. The track itself was 21 inches wide, fitted with replaceable rubber pads that could be swapped out when worn, a feature that dramatically reduced maintenance time compared to the fixed pad tracks of earlier tanks. The M41 saw combat in Korea during the final months of that conflict, and later in Vietnam, where its light weight allowed it to cross rice paddy dikes and wooden bridges that would have collapsed under a 50-ton main battle tank. It was also exported widely, serving in the armies of over a dozen allied nations through the 1970s. Diesel repower kits, developed by aftermarket companies, extended the service life of many bulldogs well beyond their original design limits, replacing the thirsty gasoline engine with more efficient compression ignition units. While tanks grew heavier and more lethal, the infantry still needed a way to reach the battlefield under armor. The M75 armored personnel carrier, fielded in the early 1950s, had attempted to solve this problem using the same Continental air-cooled engine and Allison cross-drive transmission as the Walker Bulldog. But the M75 was expensive, mechanically complex, and most critically, it could not swim. Troops had to dismount and cross rivers under fire, or wait for engineers to bridge the obstacle. The Army wanted a vehicle that could float. The answer arrived in March 1954 with the M59, a fully amphibious armored personnel carrier built by the FMC Corporation. The M59's hull was a welded steel box, shaped like a blunt-nosed barge with a trim vane at the front that could be raised to deflect water over the bow. When the vane was deployed and the bilge pumps activated, the M59 could propel itself through calm water at walking speed, its steel tracks churning against the water and pushing it forward. No preparation was required. The driver simply drove down the riverbank and into the current. Power came from twin GMC 302 six-cylinder gasoline engines, the same basic units used in the M211 2.5-ton trucks, mounted in spunsons above the tracks on each side of the hull. Each engine drove a hydromatic automatic transmission, and the outputs were synchronized through a complex system of drive shafts, right-angle gearboxes, and controlled differentials in the front corners of the vehicle. The twin-engine layout was a deliberate cost-saving measure. The M59 used off-the-shelf truck components rather than expensive tank-specific power packs, making it cheaper to build and easier to maintain. But the two small engines, each producing only 127 horsepower, were barely adequate for the vehicle's 42,000-pound combat weight. The M59 was chronically underpowered, particularly when climbing steep grades or pushing against strong currents. The crew compartment could seat 10 fully equipped infantrymen, plus a driver and commander, for a total of 12 men. Entry was through a large rear ramp that lowered to the ground, or through a smaller personnel door set into the ramp itself. A 50 caliber machine gun was mounted on a pintle in front of the commander's hatch, and later, M59A1 variants enclosed this weapon in a small rotating turret that the commander could crank by hand. The M59 was never perfect, but it was amphibious without preparation, and that single capability justified its existence in an era when every river in Europe was a potential front line. By 1960, the Army was ready to replace the M38A1 Jeep with an entirely new vehicle, one that shared no parts with its predecessors and represented a clean break with the past. The M151 MUT, an acronym for Military Utility Tactical Truck, was designed by Ford to a military specification that demanded independent suspension, a unitized body, and the lowest possible silhouette. The result was a four-wheel drive vehicle that looked like a Jeep, but was in reality a completely different machine. The most radical departure was the suspension. Instead of solid axles on leaf springs, the M151 used coil springs and A-arms on all four wheels, a system that gave it a remarkably smooth ride over rough terrain. Each wheel could move independently, soaking up bumps that would have rattled the teeth of a driver in an M38A1. But this same suspension geometry had a dangerous flaw. The pivot points for the rear A-arms were angled in such a way that, during a sharp turn at speed, the outside wheel could tuck under the vehicle, causing it to roll over. The problem was not fully corrected until the M151A2 variant, which redesigned the rear suspension arms to pivot from front to rear rather than side to side, improving stability but never entirely eliminating the risk. The body was a unitized steel stamping, with the frame rails integrated into the floor pan and the front fenders and bumper welded directly to the hull. The hood, grille, and windshield were the only removable sheet metal components. This construction method reduced weight and simplified assembly, but it also meant that collision damage was harder to repair. A bent frame rail, which could be unbolted and replaced on an M38A1, now required cutting and welding to fix. The engine was a 141 cubic inch overhead valve, 4-cylinder, producing 71 horsepower, mounted in the conventional front engine position, but with all accessories redesigned for military use. None of the parts interchanged with the earlier Jeep engines. The M151 was used extensively in Vietnam, where its lightweight and compact dimensions made it ideal for the narrow jungle trails and congested urban streets of that conflict. Deep water fording kits allowed it to cross flooded rice paddies, and a 100-amp generator kit powered the increasingly sophisticated radios that filled the rear compartment. Removable canvas tops and side curtains provided minimal protection from the monsoon rains, and a gasoline-fired heater kept the crew from freezing during the cold Highland nights. The M151, like every military vehicle before it, was asked to do more than its designers had ever intended, and like its predecessors, it usually managed to deliver. The final transformation of the post-war fleet came in 1965, when the M35 2.5-ton truck received a new heart. The Rio OA331 gasoline engine, a 331 cubic inch overhead valve 6 that had powered the M35 since its introduction in the early 1950s, was replaced by the Continental LDS 427, a turbocharged multi-fuel diesel that could burn almost any liquid hydrocarbon. Diesel fuel, jet fuel, kerosene, heating oil, even gasoline mixed with motor oil. The LDS 427 would ingest it all, compressing the mixture until it detonated under its own heat, though its 130 horsepower output demanded careful gear selection on steep grades. This capability was not a convenience. It was a survival mechanism, designed to keep the trucks running when supply lines were severed and fuel purity could not be guaranteed. The LDS 427 was turbocharged, but its 130 horsepower output was only a modest increase over the gasoline engine. The real leap in power came later with the naturally aspirated LD 465, which produced 210 horsepower in the M35A2 variant. That engine required a heavier clutch, a stronger overdrive transmission, and an air-shift transfer case that replaced the older Sprague-type engagement system. But the basic truck remained the same: a simple, rugged six-wheel-drive vehicle with a 12-foot cargo box, troop seats, and a canvas top, capable of hauling 5 tons off-road and 10 tons on the highway. The M35 served in Vietnam, the Cold War, and Desert Storm, and some variants remain in service today. Over half a century after the first Rio prototypes rolled out of the factory, the M35 was not a revolutionary design. It was an evolution, the final expression of a lineage that stretched back to the CCKW of 1942 and the GMC commercial trucks of the 1930s. But that was the point. The Army had learned, through 2 decades of trial and error, that radical innovation was less important than reliability, that a vehicle that could be repaired with basic tools in a muddy field was worth more than a vehicle that could set speed records but needed a fully equipped depot to service. The M35 embodied that philosophy. A truck that could be maintained by any mechanic, run on any fuel, and keep moving long after more sophisticated machines had broken down. The legacy of the American military vehicle program from 1940 to 1965 is not found in museums or private collections, though thousands of these machines survive in those places. It is found in the design principles that became standard across the automotive industry: 4-wheel drive as a consumer option, synchromesh transmissions, sealed electrical systems, and the expectation that a vehicle should start in sub-zero cold and run in desert heat without complaint. The Jeep evolved into the civilian CJ and the modern SUV. The Dodge Power Wagon, a direct descendant of the WC series, became the template for every heavy-duty 4-wheel drive pickup. The engineering knowledge gained from building 500,000 CCKWs flowed into GMC's post-war truck line, and from there into the commercial vehicles that built the interstate highway system. The men who designed these vehicles are gone now. The veterans who drove them are fading, but the machines themselves, restored and preserved by collectors, still rumble to life at rallies and parades. Their L-head engines chugging with the same steady rhythm they carried through the mud of France and the coral dust of Pacific islands. They are not relics. They are the physical memory of an era when American industry, given an impossible challenge, simply built its way to victory. One truck, one tank, one Jeep at a time. If you have a story about a father or grandfather who served in World War II, Korea, or Vietnam, and you remember the vehicle they drove, we would love to hear it. Share those memories in the comments below and help us keep the history of these remarkable machines alive. If you enjoyed this documentary, please subscribe to the channel and give this video a like. Thank you for watching.